Hey guys, been here. Yesterday we modeled this curtain wall, so it's a parametric concrete precast concrete wall. And today we're going to use a different method to model this. So it will be a so like this one. It will be a line-based family. Okay, so let's do it. So first we need to create a face-based family. So generic model, face-based. Okay. So this will be the void. So we're going to create some void and then cut into a solid. So okay, so in this floor plan, create some reference plane, and then di dimension and equal another dimension. So this one will be the height. Let's create a h instance. Okay, and another, this one will be the width instance. Okay, so now go to front view. We're going to cut into the base, so I'll just create a reference plane under this level, reference level, and create a dimension. So let's go back to have a look at this curtain wall. So see, here are the dimensions for the thickness. So the void is 150 and the panels, the solid part is 50. So what we're going to do is I'll just type in 150, and this will be the steps of this void. So I'll just lock it because in this exercise it's not going to change, so it's we don't need to create a parameter for it. So okay, so now go back to floor plan, and also if you look, if you did this exercise yesterday, we will know that this face, the bottom volume is straight, it's a rectangular shape. All the rest is they are not straight, so you will see that's 20 from this line to this line, and also that's 20 from this line to this line. Okay, so now go back to this void family. So go to the floor plan. So we just need to create some more reference planes. Okay, so not this one, but all the other three. Dimension on them. And because it's fixed 20, so we don't need to create a parameter. Just need a dimension on them, which is 20, and then lock them. Okay, so now we can start to create this the void. So we're going to use void blend. Okay, so first let's check the work plan. So set work plan. So have a look at here. So reference level, which is okay, good. So then create a rectangular shape. So the first one, the top one, we're going to pick the external reference plane. Okay, and then click on edit top. So this time, so we're going to pick the reference line. Okay, so go to front view. Sorry, reference plane, not reference line. So set work plan, pick a plane. Okay, pick this reference plane. Okay, go back to floor plan. So and then create another rectangular shape. So this time pick the interior one. Okay, so unlock them. So finish. So now if you go to 3D view, you will see actually it's not right, because if you select this void, you will notice that's 2, because we picked both reference planes, so we can just use 0 for both of them. Okay, so now this is a void. Okay, and then we can just cut this void out of this solid, out of this base. So now this is the void family, and that's it. It's finished. Now we can create a line-based. Let's create a line-based generic model. Okay. So first, let's go to the left view. So I'm going to create a couple of reference plans. So the first one will be the height of this wall. So H instance OK, and this one will be the thickness, because we know that the thickness of this wall is 200. So it's fixed, so we don't need to create a parameter. But if you want to make this adjustable, you can always create a parameter for it. Okay. So now we can create this solid wall. So I'm going to use a sweep. So I'll go to 3D view and create a sweep bar. Use this pick path and then pick this reference line. And OK, and then go to left view, edit profile, pick line, lock, 1, 2, 3, 4, trim TR, and that's it. So finish. So now if you go to 3D view, you will see this is the wall. And if we change this, so for example, change the height. Yeah, all good. Change the width. Yes, all good. Okay, so now go to front view. So we're going to create some reference plans. Okay, so first these two will be the edge on each side. So dimension done, and because they are fixed, so 440 on each side. So we don't need to add parameter for them. So we just need to just type in 440 and lock them. Okay, so 440 and lock it. And then we can create. We need to create another 2 reference plan. So this time, this will be the top width of the edge mullion. So which is 290. This one's 200. So we just need to type in 290 and lock it. So this one will be 200 and lock it. Okay. So next we need another reference plan. So this time this will be the width of the void. Okay. So now we need to add a parameter for it. So we'll call it a void width and instance, and OK. And then we need to add another one. So here, so this will be the void width as well. Okay. And then another one, reference plan. So this time this will be the middle mullion width, which is 80. Okay. So that's just, actually we don't need a parameter for it because it's fixed distance. So 80 and then lock it. Okay, so what's next? Okay, so next we're going to add 1, 2, 3 reference plan. This reference plan will help us to locate the void. Okay, so I'll just add dimension to them equal. So this will be center of this void. Okay, same dimension equal, and also this one equal. So this will be the center of the void. Now we can go back to the void, and let's load this into this solid wall. So I'll just place it here, so you will see it will automatically cut void in this wall. Okay, but the size of this is not correct. So first I'm going to select this one because we have this width and height. let's create also the width. We already have this one parameter, so we can just link this to void width. But for the height, we still need to create a new parameter. So we'll call it void height instance, and OK, and OK. So now if I go to family types, the void height equals the overall height minus the top one and the bottom one, which is 290 and the 200. So it's very simple. So I just void height equals h minus 490, and that's it. So apply. You will see this void instantly match this. Okay, so now I'm just going to align this void to these two reference plane. Okay, so align and lock, and also align and lock. Okay, so this is the location of the first void. Now I'm going to create an array, so AR, and make sure you use last. Okay, so I'll click here, and the second one will be, I'll just place it roughly here, and I'll just use 2. It's fine. Click it here. Instance origin does not allow, maybe because it's come off this face. That's okay. Let's try to just move it still inside this face. So AR still last. That's good. Here to here. Okay, and click. Okay, so this time it's better. Now let's align this to here, these two reference planes. Okay, so align, lock, and also this one, align and lock. So now this location of the first void and the last void is done. It's done. We just need to work out how many void we need and what the exact the void the width need to be. Okay, so first we need to work out what the maximum void width is. So yesterday, so we when we set this curtain wall, we have this one. So this is the maximum spacing. So okay, so which is 810, and also 810 is from the center of this mullion to the center of this mullion. Okay, because this mullion is 80 width wide, and which means 810 minus 80, so will be 730, right? So now let's go back to this. We're just going to create a new parameter. So let's call it max width. Oops. It will be instance, and also it will be 730. Okay, and also we need to select this one group member of this array and click on this line, and then add a parameter for this array. We'll call it number. Okay, instance. And now we need to work out, first we need to work out how many of this void we need. So let's go to family types. Okay, so I'll just quickly, actually I did this before, but I'll just do a new one. Okay, so now this is the overall length. Okay, and then we know this 440 and 440, and so after we get rid of these two, so what left is L minus 80, right? And in this, so we're going to have I'm not sure how many, but I'll just draw it like this. So we will have 1, 2, 3, and 4 void. Okay, and then we will have 1, 2, and 3. So that would be the mullion. Okay, so 3 and okay. So what I'm going to do is if I L mine, because we have 3 number of boolean and 4 of void. So if in this number, if I add one of the boolean and then divide by the void plus boolean, this will give us the number, right? Divide by void. So okay, so this is the formula for this number. So let's do it. So first, length minus 880 plus m in here is 80, right? Bracket minus bracket void. Void is a maximum void. Okay, so max width plus 80. Okay, so this will give us the number of void. So if I click apply, still not right because the void width is not correct yet. Okay, so don't worry about this. So now we just need to work out the actual void width. So it's similar to this, actually similar to this. So still we're going to use this one, okay, L minus 880 plus, so which is the middle part, plus 1 boolean. But this time we're going to minus it by the number. So this will give us the width of one of the void plus one of the boolean. And then if we minus one of the boolean, and we get this void width. Okay, so let's do it. So I'll just copy this because it's quite similar. So more width minus the number. Okay, and then once again minus the 80, which is the boolean width. Now this is the actual width. So if I apply, that's it. So you will see we have 660 void width, 80 boolean width, and then all the same. Okay, so actually I'm going to have a test to see if the maximum width will be 730 exactly. Okay, so what I'm going to do is I'll just do it. I'll just change the length of this. Try 4 meter. 720, still under that, which is good. Oops. No, that's not right. So you will see this void width, actual void width is larger than this. Okay, so which means the number here is not right. We need actually, it's probably because the number from this formula is 4 point something, and it's because it's smaller than 4.5, it becomes 4. So this is the issue. So what we can do is we can just add a round up in this formula. Okay, so now you will see it becomes 5. So once again, if I apply, so this time it becomes 5 void. So let's try it again. So let's change it to 4 meter again. So see, 420 or 720. Let's add slowly. So 40, 50, count 40, 20 maybe. 725, 30, 727.5, 3, 5, almost there, 9, 40. See, this is the maximum width. Okay, so and then if I add one more, 1 millimeter more, it will go back to, increase the number and reduce the width. Okay, so this is exactly what we want. Okay, so that's it. So you will see this family. So compare to the curtain wall family, I think it's simpler. And also you won't see all these lines. So all these lines. This family looks like just one single piece. Okay, so let's have a look in. I'll just create a project and let's load this into this project and the test. So it's a line-based family, so which you can just draw, like it's just like draw a line and actually create a family with that certain length and let's create similar CS. So you will see you can just very easily create different instances with different length. And also let's change this height. No problems at all. You might notice that little thing there. So these line, these are because the size of the base of the void family is too small. So you can easily just select one of the void family and go here, just drag this base size, increase the size of the base and load back into the family here, and then let's load this into the project and you will see now it's gone. Okay, so that's it. If you have any question, please let me know. I'll see you next time. Bye.